All right, so let's take a look here at this equation. We've got a trig equation that's in a single trig function. It's in cosine, and it's cosine of 3x. So let's get that by itself. So let's add 3 cosine 3x to each side and get 4 cosine of 3x is equal to 2 radical 3. And then we'll divide both sides by 4. We have that the cosine of this angle 3x is equal to radical 3 over 2. And we want exact values now, so we won't have to use the calculator. We can use our unit circle. If you look at your unit circle, I don't have a copy of it pulled up. If you look for an x coordinate that is radical 3 over 2, you'll find it at pi over 6, which is 30 degrees, because they've given us the constraint in degrees, so therefore we should work in degrees. There's also going to be a point down here in quadrant 4 that has an x-coordinate of radical 3 over 2, and that's going to be 330 degrees. This 3x is a horizontal shrink by a factor of 1/3, so it's going to complete one cycle in a third of the length that it used to. So we're going to lose solutions. Let's take this 3x and set it equal to 30 degrees. And any angle that is coterminal to that. So we'll add integer multiples of 360. Now, for this other point, let's take this 3x and set it equal to 330 degrees and any angle that is coterminal to that. So if we solve here for x, let's divide everything by 3. And we've got 10, 120. And over here, if I divide everything by 3, let's shrink this up, kind of right big. I need some more room. All right, so let's construct a table, and if we start changing, plugging in integer values for n, we'll be able to come up with solutions that are between 0 and 360. All right, so let's call these solutions 1 and these solutions 2. We're not going to pick negative negative integers, because that would make that result negative, and we want to be bigger than 0. So if we let n be 0, we've got 10 degrees. That's between 0 and 360. And in this other one, if we let n be 0, we've got 110 degrees. Well, if we let n be 1, then we've got 120 plus 10, 130. And here, 230. If we let it be 2, 240 plus 10 is 250. If we double this, we've got 240 plus 110. So if I have 240 and 110, I've got 350. And that's definitely below 360. So we can see that if we go out to 3, that's going to be 360 plus 10, which is 370. That's bigger than 360. If we let this be 3, we're going to get 360 plus 110, so that's bigger than 1 revolution. So no need to even fill these out. Can keep working with these. All right, so these 6 solutions should be a solution to that equation. Let's see, is there an easy way to check? Let's go to this. Since we have cosines on both sides, we isolated that cosine, and we had the equation cosine of 3 times our answer was equal to radical 3 over 2. So let's check that real quick. What decimal is radical 3 over 2? So 0.866. All right, so if we plug in one of our answers, say 10 degrees, into this equation, let's make sure we're in degrees. The cosine of 3 times that angle, 3 times 10, 30. And that is that 0.866 that we saw just a minute ago for the decimal approximation of radical 3 over 2. What if we plug in 110? What if we take cosine of 3 times 110? We get that same value. Well, if we take cosine of 3 times 130, we get that same value. Cosine of 3 times 230, same, and cosine of 3 times, where am I at, 250, and the cosine of 3 times, 350. All right, so those all look pretty good. And like we say, 3 was too big, so here's, I'm not going to write those again, but our table there, let's highlight it. Our table, these guys are our solution set. It's between 0 and 360. All right, well, I hope that helps, and I'll talk to you later. Bye.